This is the final day before deadline.
This is like the last 3 hours of the game. And you have like somebody.
Testing one. Okay, everyone, welcome back to EECS 498 Game Engine Architecture. A question, I'm always curious, so I actually get better attendance in this class than I do in 494, if you can believe it. And what I'm wondering now is how many of you are here for office hours mainly, but you're just going to kind of catch the lecture, because why not? No? Okay, let's go. All right. Okay, so you are right in the middle of homework 5. Now, I know that actually very few of you have even started homework 5. So I get email notifications every time you submit anything. We have a very long record of how you've done that will be there forever, okay? I even see those of you who started homework 3 last night. So please, if you feel like you're falling a bit behind in the course, right, come to office hours. We can often speed you up, all right? We can help you out. But you are in the middle of homework 5, and this is a very serious homework, okay? It is not tremendously long, okay? Not super long, but the things you're going to do in this homework are extremely important for setting you up for future homeworks, okay? The good news is that after this homework 5, you'll have your first 2-week-long assignment, Continuous Worlds. Sounds fantastic, right? In fact, Continuous Worlds only has 6 test suites.
No way.
That's all I'm going to say, okay? That's all I'm going to say. Anyway, you will get a bit more time to catch up, but again, right, we give you 2 weeks on homework 6 because we think you're going to need it. Okay, homework 7, you get 3 weeks, but it's only designed for 2 weeks. Why? Because we want you to not do anything over spring break. This would be a time you could catch up if you need to, but really we hope you're going to kind of keep up with the assignments so you don't need to spend your spring break catching up. You can use it to recharge, refresh for the final push at the end of the course, okay? During and after spring break, the course gets really fun. Homework 7 and 8, I think, are absolute bangers. As far as assignment goes. And hopefully homework 9 will be much in the same vein. But yes?
You mean making a window on screen isn't fun?
I think it's pretty fun. How many of you have got a window running? Okay, you built and ran your program and the window pops up, you're like, oh, yeah. It's like a little dopamine hit, right? A little bit of mental sugar. And it's exactly how I felt too, right? So over the summer break, I cloned my engine down. Actually, I downloaded the binary of my engine, put a resources folder next to it for the game, and I launched it on my Raspberry Pi 5, and it just ran. It just worked. It was super cool. It worked a really high frame rate. It was awesome. Anyway, so let's go ahead and get into it. So I've got an engine for you today, and like normal, we'll go through this one pretty quickly. This is Frostbite. So the other day we talked about Renderware engine. Renderware was a famous engine that was cross-platform. It was made by a studio called Criterion, used in their Burnout series of games, but also used in tons of games, GTA, Sonic Heroes. And this engine was cross-platform. It was also third-party licensable, so if you got the coin, anyone could use it. Well, EA purchased Criterion, and suddenly, renderware died. It disappeared, okay? It went out of service. I think it was used a little bit internally, but it quickly kind of went away. Fortunately, EA had another team working on their own engine tech, but it was only going to be used internally. They had the team in, is DICE in Sweden? Sweden? Is that it? Stockholm? DICE? Where is DICE located? Either Finland or Sweden. I can't remember. Okay, hold on. Where is EA DICE? Stockholm. Okay, out there in Sweden. So I feel like it gets so cold in that part of the world that, like, those long winter days, you might as well stay inside and make a great engine. Okay? And so DICE, which is famous for the Battlefield series of kind of military first-person shooters, created this engine, and they created the Frostbite engine with destructible environments in mind. And I remember as a player in that era, right, on the Xbox 360 era, it was very rare to have fully dynamic, destructible environments where a building would fall apart around you as you fought through it. But DICE's games were some of the few that kind of had that. And it was really a great selling point for those games. This is a video of showing off some of the engine's features in 2014. Okay, so let's take a look.
Frostbite's been in development since 2006, and there's always been a roadmap and a plan for Gen 4 and beyond. So I like to think of Frostbite as an evolutionary process, and Frostbite 3 is the next step in that evolution.
Frostbite is a really powerful tool. A gamer is going to experience a much more authentic, movable, and realistic-looking game.
We have one unified program where you can create content that runs on everything from an iPhone to next-gen console. And now it's really coming online and enabling the game designers to do way more than they've ever been able to do before.
We spend significant effort on creating more dynamic living environments.
Before, they would have to go to a lot of work to make a tree feel like it's weighted in. Now we give them the tools to create the tree, and we let the game control how the wind affects that tree.
Frostbite allows everything to work together. The waves on the beach, the wind blowing by gaps, even the clouds overhead move consistently with the forces of nature.
You might see an explosion go off, you'll see the trees nearby shake from the explosion.
It's sort of subtle, but it creates this sense of seamless reality. So the large world coupled with a lot of people running around interacting with you really pays off in Battlefield 4.
Destruction has always been a core feature of Frostbite, and
It's the evolution of the way the environment is impacted by input. Everything from the smallest spark lighting, but also gigantic chunks of debris that rumble when they impact the ground.
The guys on Battlefield 4 have been working on something called evolution.
Evolution is really about the concept how you can drastically change a multiplayer into something different. It could be anything from a building collapsing or to a dam leaking or anything really big game changing level.
A recent feature that we put in Battlefield 4 is our network water simulation. So what this means is all players will see the same wave in the same position at the same time. And this leads to some pretty exciting cat and mouse type gameplay where you're ducking down and going up and you peek around as you drive your boat.
It will no longer swim on a flat surface, instead it will be affected by the different waves and everything. And that counts everything from living characters that are swimming, but also the dragons.
Something like a jet crashes into the ocean, you'll see the water react and the debris will then float on the waves. It's a very, very cool dynamic engine. Things just happen and it seems right.
Okay, so cool stuff, right? It's a very powerful engine. One of the things that has been haunting AAA lately in 2025 is the fact that games from 2014, from a decade ago, look fantastic. how do you sell a new product? How do you sell new experiences when the old experiences are as competitive as the new ones? It's a tough problem, okay? Of course, this is coming from someone who thinks the PlayStation era games still look incredible in their own way. So, yeah, maybe I'm unique. Okay, all right, so one really interesting thing is that, there's actually a SIGGRAPH presentation I linked for you if you're curious. You can kind of read through. A lot of these proprietary engines don't always contribute to public knowledge in the way that you would hope for because they are meant to be internal, proprietary, right? EA funds the development of this engine so that their games have a leg up on Activision's games, on Microsoft's games, right? But sometimes they do talk about new techniques and they do contribute some ideas back. So this is kind of how they do holes and destruction in a way that's going to be very efficient for things like game consoles that don't have a whole lot of processing power to make them happen. Okay, this is another really good example of a engine that has, on occasion, really bitten some dev teams. Okay, so this is an engine made by a first-person military shooter team for first-person military shooters. But what happens when you ask an RPG company to try and make an RPG with this engine? Why would you do this? My question, why would you do this? What's the point?
If you want to make use of the more sprawling environments or the better shooter aspects behind the engine, that could be why you want to shoot it.
Yeah. Maybe your RPG game is going to be designed to be a bit like a shooter, right? But there are some other reasons. If you're EA and you have an internal engine, one you don't pay any license fee to use, one you would like to improve over time, right? Does that provide an incentive to have all your teams use it? And that's one of the issues that plagued the team behind Mass Effect Andromeda, okay? This was a game that has its own What Happened video, which is a really fun series online. Grave dancing is not something I'm a huge fan of. One of these videos do really well is they dive into what happened and, more importantly, why. They do have kind of a lighthearted tone.
Well, the idea of so much explorable real estate was BioWare's faux pas. The next one was 100% Electronic Arts is doing. You know they were coming eventually. Around this time, EA would start mandating that all their studios need to switch to DICE's Frostbite engine, as it is immensely powerful and doing the things it was designed to do, which was to run first-person shooters and not really much else. There were no solutions for things like inventories, party management, just about everything you could expect in an action RPG. Why EA thought this was a good idea is, I honestly don't have an answer. When everything is done in first person, or if you're playing a multiplayer match, you don't really need expressive animations for your character because you tend to not see them. BioWare Edmonton, however, also had to use Frostbite for Dragon Age Inquisition. Well, they fortunately did create a lot of the systems they needed for that game, which did help out the Montreal team with some even more basic features and functions they had to make from scratch for themselves. This in turn cost them a lot of time in the process, which, in case you guessed it, will be a running theme.
Yes, so this was another case, in addition to the Final Fantasy XIII series, where a game engine just wasn't quite up to snuff with what the team needed. Thus, the team had to make a game and make an engine at the same time. Another case here was that the DICE team, that does have a lot of experience with the engine and can help make features for other EA teams, they're not huge, okay? They are busy with other projects all across EA studios. And so, in some circumstances, like the team would have to wait quite a while to get support from the engineers who really know what they're doing, or they just have to go wing it themselves to sometimes disastrous effect. In any case, the mandate that teams use Frostbite internally is now thoroughly dead. And you can see that in games like Respawn, right? Respawn Entertainment making Apex Legends with the Valve's Source engine. Jedi Survivor, which is a recent game they made, was actually using Unreal Engine 5, okay? And so, there was some speculation that the next Sims game would use Frostbite, which is would be an interesting combination. I do not know if that is still the case. It is my impression that they've made something of their own. because the footage I've seen of Sims 5 is very game engine-y and very customizable. There's footage out there for any of you who didn't see it. It's basically Sims the game engine, from what I could tell. Anyway, okay, so some quick fun announcements. This is actually an announcement from last year, but the autograder, has anyone actually used the EECS GitLab server before this course? Okay. How many of you never really used it in a substantial capacity? Okay. I think that's the case for a lot of people. You could use the EECS GitLab server, or you could use the global GitLab server, which most people would do, or GitHub, which is even more popular. This course, when it came into existence, started pounding the EECS GitLab servers like nothing ever had, checking for commits, right, cloning stuff all the time. So I got a wonderful email from Don Windsor, who's a really fantastic person. We're very lucky to have him running Department's Technology, DCO. But basically, he was saying that one of our servers just started going thermonuclear, and we're not sure what's going on. It's been struggling for several weeks. We looked under the hood to figure out some clues, and they found a Yarger slash. Wait, do we know someone with that unique name? Is that Yarger's unique name? And so he pinged me and said basically, hey, is this you? You guilty? And I immediately thanked him and the department for this wonderful server they've set up. And I also reduced the rate at which the autograders do their checks to try and reduce the load on the server. Eventually, I'm going to create a central queue for all grade requests, and that will dramatically lower the server load. But I'm designing a new course right now, so that might have to wait until maybe not even this summer, but next summer. We'll see. Okay. Wait, next summer? Yeah, it's the one coming after. Yeah. Okay. Summer 2026, probably. Okay. Autograders and helper files received a very large update last night, and that's going to happen on occasion as I try and fix the nefarious and dastardly off by 1 pixel error, which is a big thorn in my side. The big problem here is that the staff solution has a certain calculation that it does. Your solution will have a certain calculation that it does. Our calculations might be the same, but if you do something to cast to an integer at a different time than I do, or if you use a different data structure that we do, the same calculation can result in slightly different final numbers, which could put your character 1 pixel off of the staff solution's location. And that is a problem, right? That causes you to fail the test case because you've got a 1 pixel difference. Very frustrating, not fun at all. How do we fix this? Well, what we do, the solution we're currently doing is we want you to try and keep your numbers as floats as long as possible, okay? Position data, for instance, right? Keep using floats until the last possible moment. In fact, you never need to cast to ints. And if you cast to ints anywhere, the autograder will probably yell at you, okay, to tell you this is a dangerous thing. What we did last night was we switched the helper APIs so that they accept floats now, okay? And I, in the helper files, handle the rounding and the truncation, the casting to int. So hopefully that will synchronize us. It did synchronize. Evan was, Ethan, yes, was helping me test this, and it did synchronize us. So I'm hopeful this will dramatically reduce the odds of an off by 1 pixel error. But here's the thing. If you ever get a grade report that has warnings on it, take those seriously and right away try and fix them, okay? Because that's trying to prevent off by 1 pixel errors creeping into your code base, okay? In any case, if you already have helper.h and audio helper, you're going to want to go get it from either the Discord or go back to the Homework 5 assignment spec where you'll find the updated ones as well. You will have to change some things. The API was broken. API calls changed. But you can fix that up pretty quickly, I think. Okay, use SDL fpoint. Do not use SDL point, that is integers. Do not use SDL rect, use SDL frect, okay? And those are the float versions of those data structures, okay? Something to remember, okay? Every single push that you make, every time you send anything to the autograder, we get a copy of it forever, okay? And so just please keep this in mind. An example, if you are not doing homework for a lot of time, or if you started things extremely late, we know that. The department will know that if it ever comes up, okay? And please think about what you are submitting to the repo. Reminder, these are actually all my repos. You just have developer invite permission on them, okay? So changing stuff later or deleting a ton of stuff, you probably can't delete the history, okay? So just keep that in mind and be sure to conduct yourself as honestly as possible, and you've got nothing to worry about. Not all students do that, though, okay? We had some people last year who tried to do some spicy things, and it didn't go so well for them. So make sure it does go well for you. Just stay honest, focus on the assignment, get those points, and you'll do just fine, okay? Okay, something that I want to show you really quickly. Let's go here into the Homework 5 solution. Oh my goodness. It's the most valuable folder in the lab right now. So what you can do here on these assignments, oh goodness, hold on. I think I can get it. Okay, UMich, GitLab. Okay, EECS. There we go. I'm going to sign in and show you one of my grade reports. Let's see here. Arger, come on. There we are. Okay, I'll show you one of my recent commits for testing stuff. Homework 5 OSX. Yeah, why not? Okay. So what we're going to have here is every grade, basically most test cases now have a downloadable test case. So something that you might think about doing, let's see here, test a vertical scale with pivot point at bottom. Does anything interesting happen here? Not really. Okay, anything happen here? No. Basic actor movement. Okay, that's kind of cool. Friend comes in, says hi. Okay, download. Okay, I want to take this right here. All right, I'm going to take this test case and I'm going to move it over right next to my code. Okay, I'm going to paste it in here. I'm going to unzip it. Okay, I'm going to unzip that test case. Now, what is in a test case? Two things, okay? We've got the resources folder, which is your game, all right? And we also have the SDL user input.txt file. If these files, especially SDL user input, if this file exists next to your executable when you go to run the game, it is going to autoplay your game. It's going to automatically play through the test case for you. Okay, and I'll show this to you, hopefully. Let's go ahead and copy and paste this out here. Yep, no resources folder. That does exist, though. If you look inside of these, it's kind of funny what you'll find. Okay, you know, look at this. What is this? This is a little chunk of data, a proprietary data format. You know, what a pain those are. But this is saying on frame 8, this key code, do this with it. I think this is saying like press right arrow key down or something like that and then lift it up. I don't know. Okay, I'd have to look it up, but the helper files do know and it can run your game automatically. Okay, I'm going to show you right here. This is your chance. Oh, this is your chance. Okay, to see some code. Okay, I'm going to go real fast. You're going to be watching a recording, I think. Oh my gosh. Okay, all right. Yeah.
It's a helper function.
Yeah. Oh. It's the helper function. Okay, I was ready for students to be like, okay, I got one frame of smeared code here. We got to like reverse the smear, and we can. Okay, okay. So let's go ahead and run this and just kind of see what happens. So we're going to run that game. I expect to see basically what we saw in the video footage there. Okay, and then it ends. Right, it ends. Basically, any test case can be played back locally if you want to. And there are some other things as well. If you switch, let's see here, if you switch recording mode in the helper file, if you switch recording mode to true from false, what'll happen is it'll actually generate a file, one of those files, okay, as you play. And that allows you to create your own kind of playback, replay files that you can then replay as many times as you want. So if you're developing and you're doing some cool things, maybe you save that and you can replicate a bug or something, all right? But anyway, you can read through this helper file to get some ideas on how it works, and you can mess with it, just not too much, okay? Because if you heavily mess with these functions and stuff stops working, yeah, that's your problem. Okay, so anyway, I think that's what I wanted to say. A quick thing, Nintendo accidentally released a PC build of a famous game called Pikmin, which you may have heard music from when you watched the integration video to calm you down. So this is really kind of fun stuff. You can see the scaffolding that developers, even secretive developers like Nintendo, put into their game.
A game exclusive by Nintendo had a secret PC version with different Nintendo employees. But when compiling Pikmin for the GameCube, they made a mistake. Every copy of the game was a Windows PC version left on the disk. Although Nintendo never published games for PC, this was released officially without anyone realizing. ROMs on post-modern PCs. When first booted up, system error appeared, because it needs a file from Windows 98 in order to even run. When the file is added, the game boots up and actually runs. It's a game window called OpenGL touched off the system, which shows a bunch of debug text for developers. It's not always incredibly formal, as when turning on Rumble, the game outputs a message saying brrr. Stretching the game makes it at a higher resolution. The HUD stays the exact same size. It can be played with just the keyboard, though some keys overlap with controls. Like the spacebar being the A button, but also being the button freezes time. Tab brings up a special menu intended for developers, with options to select a level, switch on debug displays, and more. Some models won't show up at first. That can be fixed by switching from generator mode to game mode in the debug settings. Pikmin's bodies up when this setting is turned on, but it also enables debug text above head. You can play the game in either challenge mode, however there isn't any sound and lighting isn't perfect. Another dev tool gives you access to a model viewer, which is in the Find Games files but inaccessible. When you're on the title screen, a cutscene editor can be accessed to tools as well. Cutscenes run at double speed and has no collision.
Okay, so basically, right, you can get into test maps, test tools, features, all sorts of stuff. And it's just amazing to me how much scaffolding and how much effort you have to put into the side tools, right? The scaffolding, we've got plenty of construction happening in Ann Arbor right now. And if you see a big building that's under construction, there's a lot of effort into building stuff outside so that people can get to the places on the building they need to be fast and effectively and safely. Then sometimes it seems that we put just about as much effort into the scaffolding that supports a game's development as we do into the actual game dev itself. Yeah, keep that in mind. It's just a very interesting thing. And again, like it's true, right? Leaks are sometimes very sad for the dev team, but they contribute immensely to the public's knowledge and our knowledge of history and what happened during the development of a game. Okay, so we got that for Pikmin, and we're all the better for it. Okay, blah 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 blah. Be careful to make sure you're updating your cache. A lot of you are creating accelerating data structures. A good example is the collision map that basically helps you understand where are things on a certain tile. Where are my actors? On this coordinate, is there anyone there, right? Really fast. When you create accelerating data structures like this, your performance usually improves, but your code quality usually decreases because you're adding cruft, okay? You're adding these data structures that now need to be maintained. So for instance, whenever an actor moves, you have to update that map, update that data structure, remove yourself from one location, put yourself into another. And all of that introduces opportunities for bugs, opportunities to forget to keep something up to date. Suddenly you've got a stale cache, you've got stale data. And so please keep this in mind as kind of a universal concept. Often, when you want to improve performance, this will come at the cost of your code clarity and your code quality. Okay? There's a reason that during most of development, actually, the game is not very optimized. Only in the last couple months of a long development cycle, multi-year development cycle, will games get a serious performance push. That's what happened on The Sims 4 in any case. The reason is that once you go in to add all these performance-improving things, it becomes harder to add things after that, right? It's harder to maintain, it's harder to add new features. So just keep all of this in mind, right? It's kind of an interesting dilemma that we all will eventually face, okay? A quick review of homework 2, okay? There was it was a hard quiz, quiz number 2. The other quizzes are not as hard as this one. In fact, I remember 1 year ago, the students got kind of blown up a bit by quiz 2, and that actually caused me to lower the difficulty of quiz 3, 4, and 5. So there you go, right? The help is on the way. For optional usage, this is kind of an interesting question. There was a Piazza question on it. Optional is really, really good for any sort of value that doesn't have a natural sentinel value. Okay, a natural unset value. What is an unset value? Well, if you have an integer that is supposed to represent health, negative numbers don't make sense for this concept, okay? Right? A health will never go negative. If it goes to 0, then you're dead, and that's the end of it, and then it goes back up when you respawn. So there are plenty of good sentinel values that make a lot of sense to mean not set, -1 being a very classic one. For strings, and all of this, by the way, was in one of the lecture slides, STD string, empty string, okay, especially for a current sprite. There is no sprite. There's no file name with no text, basically, no name. That would be a very, very unusual if that were even possible. So what else do we have? Actor, so any sort of pointer, kind of like in C#, right, or managed language, Java, you can always use null pointer, okay, for that to mean not set. What else do we have? You have an integer variable x position. The big dilemma here is that there's no good sentinel value. You might say, well, how about the maximum integer? But like, if a player runs for a long time, that could be a problem, okay? So sometimes if I'm lazy, I'll use a sentinel value, a position sentinel, as being like -999, -999, -999, because it's very unlikely anyone ever goes there, but it is theoretically possible. So for an x position, right, where someone could go to -1 or -2, or 1 or 2 or 0, valid positions, that's probably your best answer, okay? You don't have to agree with me on that, and if you don't, tell me why, but that is the answer this semester, okay? Benefits of header-only libraries, okay? We missed this one on occasion. Header-only libraries are very nice. They're very easy to include. This is what you've had on homework 3 and 4. Homework 5 is different, okay? Homework 5, we have things to link. SDL is not a header-only library. Thus, a couple things will change, okay? With header-only libraries, very convenient, only a couple steps. Basically, all you have to do is set up your header search paths, your include search paths. No libraries to care about, very convenient, but not super fast, okay? Because you will have to compile all of those headers. All the source that is included in those headers, you're going to have to compile it, okay? You can't just do a quick link to a binary that's already been compiled. Security isn't super relevant to my knowledge. Efficiency, definitely not more efficient. So there you go, right? Okay, shallow copy, all right? Anyone remember this problem? The Pokemon, the Pal World, okay? Any Pal World fans? Okay, I wasn't throwing shade at Pal World, okay? I researched the game, and gave it a lot of my time just for this question. So you have a PAL structure right here, okay? And this is another question that comes pretty much directly inspired by a lecture. PAL ID, PAL name, X position, Y position, all these pointers in here, okay? You got a bunch of strings and then a pointer to one of these strings. So this could be, in your head, you should be thinking, uh-oh, I hope they remember to update the pointer, and I hope they remember to update the ID if they were to make a shallow copy, okay? Because those are the two things that tend to get messed up bad. Anyway, we have an unordered map, okay, of enemies. And this enemies array, as we spawn in the new enemies, we do create new pals. We're doing shallow copies here. And we don't care or do anything with the pointer. So the pointers are messed up, but that's not what's going to cause our crash, okay? So no crash happens. In the map, however, right here, we use the pal's ID to key, but we've forgotten to give it a new ID. We've forgotten to use the next PAL ID value to set the new ID. And so we've got a bug, okay? We're basically just setting and replacing the same key with new PALs over and over 100 times. We will only end up with one PAL in our actual dictionary, okay? In our map. So that's what happened there, okay? I try and only include a small handful of those longer questions because I know they take some time to stare at. Pointer invalidation. Okay, this question is kind of fun. So we've got a array here that goes 30275. Okay, and the player is actor ID 0, and we actually key into that right here on line 9. Okay, so player ID is now pointing at the player. It's pointing at that index 1. Okay, 0, 1, 2, 3, 4. The problem is we then sort it. Okay, this invalidates the pointer. This invalidates the pointer, but it's still usable. Okay, and we can tell and say what it's going to point to. Okay, when this is all reordered, it's going to be 0, 2, 3, 5, 7. Okay, in ascending order. That's what the hint is for. Yeah, so the hint. Whenever you see a hint like this or a note, it's like, be very suspicious. Okay, it is pointing you to what we want you to be thinking about. Anyway. So we output the pointer. What is the pointer pointing to? Whatever's at this, which will be the value 2 after the sort. Yeah.
Does the sort have the ability to move the vector in like heap space? It might
I don't think it does. Does it?
STD sort uses quick sort for most of it, so I believe it's an in-place sort.
It's not a stable sort, if that's what you're wondering.
It's not.
So there's a function called stable sort. But yeah,
sure
it shouldn't be moving it around. That does not seem very fast to be doing
something
that.
like merge sort would move things around, but I'm pretty sure it's an in-place sort.
Yeah. Okay. So if you want to go create a technical demo and get a point back by doing so, you can go try it. Okay. I've done that before. Sometimes students have found like unique cases where Austin, technically this is not always true. Okay, good job. You get your point back. All right, anyway, today our mission is to finish introducing SDL. We did that at the last lecture, and it's a lot of material, okay? It's a lot to digest, and it's stuff you need right now, okay? I do recommend if you have not started homework 5, well, if you're a bit behind, you got to do what you got to do, okay? But if you can start homework 5, I would implore you to do so very soon. We're going to go over SDL. We're going to finish up talking about it. And then I'm going to talk about a topic that is a little tiny bit tangential to the course because it's optional, but it's not really tangential to game engine development as a field, okay? We're going to talk about 2D positioning. We're going to talk about the classic transform component and the transform matrix, okay? How many of you have taken a linear algebra course, okay? How many of you have pretty much forgotten basically all of it? Yeah, so that's exactly what happened to me, and so we're going to go over a tiny bit of it. I'm going to try and make it a little bit more natural to you. One problem I always had with math was that I struggle to learn math and care about it before I have a good application for it. And here you will finally find, I think, a really cool application of linear algebra, okay? And hopefully that will maybe get you back into it. Anyway, let's go ahead and get to it, all right? I don't have any questions on anything I've talked about so far. Okay, cool. Oh yeah, so we are toward the end of this lecture here. Okay, so if I recall, the last thing we did was we got this beautiful point to render. And if you can't see it, okay, now you can see it, okay? Our point is flying. We are updating stuff. Now note, if you use this kind of code, the auto grader is going to yell at you, okay? This will get up and running. It will work on your machine just fine. But when you go to submit to the auto grader, it's going to want you to use the helper version of these functions, okay? And for instance, you won't use delay at all because my helper script will calculate what the delay should be based on whether it's on the autograder or not. But in any case, so let's say you've gotten to this point where you are rendering this pixel just fine, okay? Very good. You're doing things like at the beginning of a frame, you are clearing out, okay? You're making the screen entirely black. On homework 5, it will actually be a rendering.config property that tells you what the clear color is. I think a cornflower blue is very common, okay? A white is a little bit common, black's common. So you, at the beginning of a frame, you clear out, so you have a nice, beautiful canvas for us to draw the next frame on. You then set the draw color. You can do your drawing operations like STL render draw point. And then if you want to actually flip the double buffer and show that to the screen, you need to then do STL render present, okay, which will conclude the frame. If you want to delay and relax, actually I do think you need this, STL delay. This is kind of like the yield in a Unity coroutine. You don't know what I just said? That's totally fine. I think you need STL delay, if I recall. Yeah.
Not with the new helper function. It has it.
Now with the helper function?
With the helper function, I added
yeah.
STL delay and I got yelled at.
Yeah. Oh, yes. Well, the helper function will call STL delay on your behalf. It does this because on the autograder, we need to ensure that STL delay 1 is being called because we want the autograder to run as fast as possible, not at 60 frames per second. Otherwise, performance isn't going to have any impact, really, unless it's really bad. Okay. So anyway, what about rendering images? We're rendering a pixel. Okay, we're rendering a point. What's the point? Okay, well, if we want to render an image, we need help from STL's image library. Okay, on homework 5, you're going to have, I think, about 4 dependencies that you have to install, serious ones. And this is one of those. Okay, when you go to use STL image, you'll want to go in STL2, STL.h. Okay, this depends a little bit on your includes and your file structure, but you will have some nice functions. One is called img_load texture. You provide the render that you're using for your window, okay? And you also give it a name or a file path, all right? And it will load whatever texture it finds there, whatever PNG it finds, into what's called an STL texture, okay? STL texture is what we want you to use in this course, not STL surface. They're kind of similar, but one uses the GPU. The texture uses your GPU, and then surface will use your CPU. So one is going to be quite a bit faster, okay? Yeah, this is a GPU side image data structure, and it is a very slow operation, loading things from disk, right? Anytime you have to go to disk, this is very slow. And so you really want to think about caching this stuff after you load the image from disk, if you can, okay? This week, not the end of the world, probably, maybe, if you forget. But next week, oh yeah, all right, you're going to want this. You then will use a function, not STL render point, but STL render copy, okay? You are copying data from a texture to the buffer, the render buffer, okay? So how do you use this function? Well, you're going to provide the render, like always, okay? This is the render that is associated with your window. And then you're going to provide that STL texture pointer, okay? Say, hey, I want to render this texture. I want to copy this texture in. This null pointer pair right here might be a little bit confusing. What are these for? Well, the first one here is a source rectangle, okay? And the second one is a destination rectangle. And so what you can actually do in STL with these functions is you can say, I only want to copy a portion of the image, this rectangle, and I want this rectangle to become this bigger rectangle on the final image, okay? That's somewhat atypical. If you provide null pointer to any of these, it will take the whole thing, okay? So take the entire hello texture and paint it to the entire window. That's how you can read this particular function call, okay? Yep, source and destination rectangles, all right? Then let's go ahead and do a render present in order to flip the buffer and see what we see. And there we go. Cool, all right? That was my hello texture. It was called hello.png on my desktop when I was recording this footage, okay? But there's a problem. Can you see the problem? No, you can't see the problem yet, okay? We're too excited. But why is it frozen? And I mean, why is the entire window frozen? Okay, any of you get this to happen? Okay, you're like, wait, what's going on here? Okay, I can't even drag the window around. I can't even click the X button to kill the window. Okay, this is not a good place to be. What's going on? It's like we've got a hard lock, an infinite loop somewhere. Okay, we can't even quit the program. Well, you would think that we'd be okay because we've got this delay here at the end that's kind of letting things run and relax. But actually, there's something that we have missed, okay? What we need to do is we need to have a smarter loop than just an infinite while loop, okay? We need a smarter loop here. We need a loop that's going to deal with events that are coming from the window. The problem here is that our Windows event queue is jammed full of events, and we have not processed them at all. We've not emptying the queue. Okay? The way that SDL works is that whenever anything happens with the window, or whenever any inputs come through, like the player presses a spacebar or right arrow key, or even when the player presses the little X at the top right corner, all of these events come through the event queue. And the event queue is where we can kind of pluck them out to see what is happening. All right? The event queue is a queue that is automatically filled with useful events every single frame. Okay? And it might look something like this. Here's our queue, and it's getting filled up. We have an SDL window event moved. What does that mean? That means someone dragged the window. Okay? Oops, we have an SDL key code that happened on this frame as well. Okay? The right key code, so it's a right arrow key. We have some other events, and then maybe we even have an event coming through called SDL quit. Are you going to tell me to keep my... Thank you. You know, eventually I'll get reminded that it's a problem when they simply turn off. But I appreciate it. When I see your hand go up, I'm thinking like, was there something confusing about what I just said? Maybe I should say it a different way. All right. So all of these events that are in the queue must be removed from the queue. Every single frame, even if we don't use them. All right? And so we have to keep this queue from being jammed. We have to go and process the queue. Well, how do you do this? It's actually extremely easy. But again, you're going to see something here that is really weird. It's C-style programming, okay? C-style programming. So here's how you process events from the queue. What you do is you create a struct, SDL event, next event, okay? You can call it whatever you want. This next event, right, it's full of garbage, okay? It's not initialized yet. But all it is a container. This is how we're going to get that event out, okay, of the queue. We enter into a while loop that checks the SDL pull event, okay? If there are more events that we have to handle, this function will actually return 1, okay? i.e., it keeps the while loop going. But if there are no more events left in the queue, then it will return a 0 and shut down this while loop. That's how we break out. Basically, do this logic in here while we have events. But if we run out of events, no more events to deal with, we exit, okay? This right here, this next event, we send in its address as a pointer, and this next event object will get filled up with whatever the next event is on the queue until we're all done. You can then use this object to kind of check, okay, what is the type of the object? And you might learn that it's an arrow key or an SDL quit, okay, or whatever. You can respond to it that way. Yes?
Does the pull event function completely pop the event off the queue that
Yes.
no longer exists? You should only call this once per frame?
Yes. Once you call SDL pull event, the next event will be popped off the queue, put into next event, and it's gone. Like if you lose this variable, that thing is history. If you want to store the event, you'll have to do that yourself. Okay? You can push a copy of it into a vector if you want. But this is how you do it. And if you add this into your code base, suddenly the window will be fine. So SDL pull event, right? It returns 1 if there are still events in the queue. It returns 0 if you're out of events. You're done. We can end the loop. That's why it was designed that way. By the way, the reason, right, this object, this function is kind of designed is so it can be used in a while loop, like it is, but also they don't want to just return a 1 or 0. They want it to be able to return more information. And this is kind of the classic way to do this in C-style programming. It's kind of annoying because you can think of this right here as a return value, right? And yet we're passing it in as a parameter? What? It's just strange. If you're used to C++ or C# or Java, you look at this and you're like, let's see, it's kind of nasty. Yep.
even in C++, I would still think to do something like that if I need to return two things from a function.
Yeah. I would typically, it might not be as efficient, but I would probably create a struct data type for like a special return type. It's not super efficient, but okay, here we go. We've just added event handling into our code, okay? Nothing crazy here. The only thing we're really doing is we're doing the SDL pull event. We're getting that next event. We're checking its type. If the type is SDL quit, then we go ahead and exit the program, as we should. The user has clicked the exit button in the top right corner. If the event coming through is SDL scan code right, that means that someone pressed the right arrow key. We should probably move our character to the right? Move our player. Just by adding this right here, now you're going to notice that our window responds beautifully. I can drag the window around. I don't get that weird cursor over the window. I can click the X in the corner, and it is back to life. Beautiful. Okay? That's a great feeling, too, once you get that working. Okay? You must drain all events. You must process them all, or you will stall out. Okay? You'll start getting timeouts on the autograder. Okay? If you're getting timeout messages, I'd be very suspicious that this could be the issue. All right? So this event queue that we just talked about is actually a fairly common pattern. You're going to see it in other places. One place you might see it is, for instance, Pygame. Okay, here you can see that the exact same approach is in play. Every single frame while you're running, okay, you can grab events out of the pygame.event queue, okay? You can check the type of event and you can do things depending on what that event is, okay? And then, look at that, flip, right? This is your SDL render present, okay, right here. Now, I want to ask you, in Unity, okay, how many of you have used Unity before? Okay, quite a few of you. How do you check if the player pressed like the right arrow key in Unity? Do you have to write all this nasty code? No, right? What do you do?
Use the old and the new input system.
Oh, isn't this nice? You can call basically this function from anywhere in the entire code base. One big challenge about this event queue approach is that this event object is only valid in this function inside of this scope. So if you want to get this event, the fact that something, hey, the fact that someone pressed the right arrow key this frame, if you want to get that fact, you want to get this object to another part of the code base, you have to hack your code to heck and back, right? Very nasty. You don't want to do that. What you want is something like this, input manager. And maybe one day you'll make one. In fact, on homework 7, you make one, and for many students, it was their favorite part of the assignment. Because suddenly, all these functions you're so used to using in Unity, you kind of wonder how they work under the hood. You just built it, okay? And it's really nice. Yes?
Do you not recommend making it for this one?
You can if you want. I don't care. Yeah, but you'll be required to on homework 7. Because this is not a C++ function. This is Lua code. Okay? You'll have to make it work in Lua. So, okay. One day we will return to the topic. All right? So I want to talk about linear algebra a little bit with you at a very surface level, and I want to talk about its application to games briefly. 2D transformations are a really big deal, okay? This is Yoshi's Island, 1995 Super Nintendo game. The Super Nintendo was much more powerful than the classic NES game that you play Zelda and Super Mario Bros. And Metroid on. Super Nintendo had a lot more features for manipulation of 2D graphics. You can see it in this boss. In fact, in Yoshi's Island, pretty much every boss is a normal enemy that gets, it basically gets a magic spell put on it by Kamek. And it grows, okay? It grows, it springs to life, it's rotating. Watch this animation, right? It scales up big, it rotates, okay? It translates, it's doing all sorts of funky 2D magic. And the question is, well, how do you actually do this, okay? How do you actually make this stuff happen under the hood? Now, we're used to, in Unity and these other game engines, well, you just make a certain function call, right? And that's how we do it. But we want to kind of know how this works, at least a little bit under the hood, okay? This is a tech demo for the SNES, okay? I got my slides in the wrong order. This is kind of tech demo stuff for the SNES. It doesn't look super impressive today, but it was super cool and very rare and new in the 90s, okay? When people weren't used to a whole lot, all right? So transform, it's all about the transform. You've probably seen the transform before. In fact, you've probably seen it in different forms across different engines. In the Unity game engine, it looks like this. And you can see that this transform in Unity is represented by a component. Every game object must have one. And this transform component has position data, XYZ, rotation, XYZ, and scale, XYZ. Okay? Position, rotation, scale. In Unreal Engine, you'll find things are much the same. Okay? You've got a static mesh component, but it does have a transform section. Location, rotation, scale. Position, rotation, and scale. In Godot, you'll find the exact same thing. This is a universal concept. It's something that is worth knowing under the hood, at least a little bit. Position, rotation, and scale. So let's talk a little bit about each of these. So 2D transformation. Imagine that you have one of your actors, okay, standing on a particular cell. Let's say this goose right here is at 0, 0. Well, what we can do is we can move it over, okay? This would be called a translation by 2, -1, all right? At least in the coordinate system we're using. I think -1 in the world of SDL and in our code base actually takes you up, right? Here it takes us down. You know, you can do the mental math translation, okay? A translation of 2, -1, all right? One way you might do this, is very simply. You might have, for instance, an SDL frect, okay, which has an X and a Y, and you might simply add to them, right? The X-axis of your translation gets added to the .X and the Y to the .Y. Very, very simple stuff, okay? And again, you do not want to be doing anything that could cause your floats to be casted to an int or truncated early. So do not use SDL rect in this course, please. Use SDL frect. The autograder will remind you of this if it ever sees an SDL rect in your project, okay? All right, so you could say, well, I want to do a rotation. This is a rotation right here of 180 degrees. And how would you deal with this? Well, you could have a variable rotation degree counterclockwise, and you might say, well, it's 180 degrees, or pi, okay? Notice the double here. You can tell these slides were created last year before we had the float policies. So I'm going to go ahead and I'm going to put a float right there on it. And there we go. Okay, little stamp. Use floats. You use doubles, autograder's going to yell at you. All right? Okay, but look right here. Look what we're doing. Okay, we've decided that after translating and rotating, we're finally going to do a scale. Okay, just like this. And we're doing a scale of 2. All right, so our character has kind of scaled up from its pivot point. And this is the kind of operation that you might do with a bit of code like this. These frect data structures, they have an X and a Y, but they also have a W and an H for width and height. And you can multiply by your factor, and you can get this kind of effect. Note, this demonstration assumes each operation is happening on a different frame. I think if you do it on the same frame, you want to do scale, rotation, and translation in that order, because I do think it messes with things. I want to talk quickly about pivot points, because you'll have to care very soon. This is your actor right here. And pivot points define the kind of center of the actor. Now, where's the default? Unfortunately, it is in the top left corner, okay, in SDL. And so what's going to happen here, this is really a very big deal, actually. What's going to happen here is that when I go to put this goose, when I go to render it at 0, 0 by default, okay, it's going to look like this, all right? You're going to run this code, and it's going to look like this. Why? Because this is why, all right? The anchor, the pivot point on your character is what's actually going to get set to the position that you want. And so it's a bit of a bummer. Okay, a bit of a bummer. And so, how could you deal with this? Any ideas?
Well, you can do some math. You know the width, you know the height. Just add in half the width, add in half the height.
Absolutely. Very good. Very good. So you can change your destination rect calculation. By the way, this is not supposed to be an SDL rect. It's supposed to be an SDLF rect. Remember? I think I forgot and messed that up in the thing. And these are supposed to be floats as well. So don't forget those Fs next to the 0.5. But you can do some math, and what you will get is a effective pivot point that is kind of moving to the center of the object. Okay? What happens? Nice. I mean, that is a bit better. Yes?
If we're using like 0.5 without the F, what is that, a double? Or
Yeah. Yep. If you have a decimal component, but you don't have an F, that's probably going to become a double, which could cause some off by 1 pixel issues, right? The autograder tries to find that and let you know, hey, we think we found a double in your file, but it might miss it, and that could cause issues and pain down the line.
And then a double is 8-bit, or wait, what's the difference between a double and a float?
Integer is 4 bytes, right? So I think double is 8 bytes.
And then float is 16?
I think float is 4 bytes, but it has a decimal component.
All right.
Don't quote me on that. Okay, but it's basically a smaller double, not much space. It's usually faster. And some of the functions require floats, thus we want to use them so that we don't have to do any casts. Okay, so render the entire actor at the origin of the scene. That's what we're doing, okay? This code doesn't look super good. It is kind of nasty, actually. We don't want to have this funky math sitting here if we don't have to. And so it turns out we actually have a better thing that we can do, okay? Here we have, I've actually changed to SDLF rect and SDLF point, okay? So we are calculating the center, don't round these, by the way. Never round any of this stuff. But we are now calculating the kind of center point in pixels of our character, putting that in the pivot point data structure, and then we're using the pivot point structure in our destination rect calculation. We can then feed that in to STL render copy, and we're in business. Okay, the code's a little bit nicer. All right, nice. Now, there are other things we have to worry about. This is STL render copy, very powerful function, but there are certain things it can't do. Okay, for instance, what if you want to rotate this? What do? There's simply no rotation thing. Okay, there's no parameter for it. Well, STL render copy comes in an X form. Okay, the EX stands for extra on the end. Okay, or extended, actually, nice and shiny. Okay. It works very similarly to the other form, but it has some additional things, okay? It has a field for a pivot point. It also has a field for a rotation value, okay? It has a field for a rotation value. It also has a final parameter, a flip mode. Do you know what flip mode does? It takes the sprite and does that, okay? And you'll need to use all of these during the assignment. So that center point value is where we can actually plug things in to automatically get our image moved, which is really nice. That kind of simplifies our math. Okay, so we can feed things in. We've got our pivot point coming in right here. No flip necessary, and I think we're okay. If you have a rotation angle plugged in here, then what will happen is you'll get some sort of render that looks basically like this. Okay? It is a counterclockwise rotation, and pretty cool. It will rotate around the pivot point counterclockwise. So if you see that the pivot point is going to be in the center of the duck, that is where it's going to rotate, in the center. It's not going to go back and forth like this and waddle on its end. It's going to rotate around its center. We got to change. We changed the rotation error to 0. One thing to note is that our duck is kind of not standing where we hoped. If this is the tile right here we want to be standing on, then we want to raise this up like that, okay? So we can choose a pivot point that is all the way at the bottom of the duck, okay? Our pivot point is going to come down here, right, when we do this. Boop, like that. Now, the pivot point is what's going to be put at the center, and it's going to look fantastic, all right, like this, okay? Excellent. This is kind of a nice kind of 45-degree art style choice. We've got a camera that kind of looks like it's kind of angled at a 45 degrees, and it's still very legible. It still has that kind of grid-based feel to it while being a little bit more realistic. Oh, yeah. Okay? This is how your characters on Homework 5 and Homework 6 work. And so you're definitely going to need to do this. You're going to see this very often on that homework. Okay? If you look at these characters in the test cases, this is effectively what is happening and where their pivot points are considered to be. All right? This angle right here, 45 degrees, right? Counterclockwise, you'll get something like that. How would you do the camera? Any ideas? SDL, actually, I don't think it has a camera function. Okay? It does, I think, have a zoom function, but it doesn't have a camera movement function. So how can you deal with the camera? Yes?
Offset where you're drawing everything.
Yeah, if you create an offset where you're drawing everything, then you can kind of simulate having a camera. And you will need to do that on Homework 5 at some point, okay? But I will leave that to you. I won't show you the code for doing that. But you can think about your ASCII camera and kind of how you dealt with that. What I want to talk about with the time we've got left is the matrix situation. All these transformations that we've just walked through, translation, rotation, scale, you can do all of these without involving a matrix. You don't have to introduce and use a matrix on this assignment, but it's a good thing to kind of at least study and know about it, because this thing shows up like crazy on interviews, okay? I've had students interviewing it like Insomniac and Sucker Punch who ended up getting faced with a matrix question and they weren't able to solve it or deal with it, and it didn't work out for them, okay? Very sad. This is optional for Homework 5. GLM is a package that has, I think, some float matrices in it. So you may be able to use that if you want to, okay? We have at least one quiz question on the following, on your next quiz. It may appear on your exam, and if you go interview at StarDoc, you're definitely going to get faced with some basic questions related to matrices, okay? And the transformation matrix is a classic, okay? This is worth learning and memorizing even because of how cool actually it is, okay? Yes, anyone know what this matrix is called?
The identity matrix?
Yeah, it's the identity matrix. You know what it does? Nothing. Exactly. It pretty much does nothing, okay? So this is the identity matrix, and it has kind of an iconic little design here. But if you've forgotten, right, matrices, you can kind of think of them as functions, okay? Matrices take an input. Does anyone know what kind of inputs we could give to this 3x3 matrix? It's kind of going back to your linear algebra. What's going to be valid for this matrix to consume, to operate on? Yes?
Anything with 3 columns and how many rows?
I think 3 rows is what you need. So here's an example, like this, okay? And if you've, so what's basically happening here, matrices are just funky, okay? You have to read them in a way that's very different from how you typically read math notation. But when you're applying a matrix to something, the matrix is almost always on the left and the input to that matrix is on the right. And the way that you apply the matrix to the input, okay, is you basically do this. Fingers down, okay? And if you wonder what 2, 4 is, this is actually a coordinate, okay, representing x is 2, y equals 4. It is stacked vertically to work with the matrix, okay? So 2 is your x position, y is your 4 position. You might ask then, what on earth is that 1 doing here? Any idea? Yes?
From what I know, you need that extra 1. It's just a 1. It
Yeah.
It's just there.
Yeah.
The reason you need it is because of the translation matrix. It's
Yeah.
impossible to make a working translation matrix unless you have
Yeah.
an extra dimension.
Yep, that's
So
right.
For 2 dimensions, you need 3 by 3
Yes.
matrices.
Yes, so this little 1 here is just something that helps the math work out, okay? It's called a homogeneous coordinate. You really want it to stay 1. And it's required for your matrix operations to play out the way you want them to, okay? But really what you do here is you simply ignore it. And so this is the identity matrix, okay? And if you apply this matrix, what's going to happen is you're going to have these operations, okay? What you'll have is the operation 1 times 2 plus 0 times 4 plus 0 times 1. Okay, right here you can see that. Of course, when you multiply by 0, you don't really get anything. You don't care. It doesn't affect the calculation at all. And so what these zeros are saying is that I don't care about your second component and I don't care about your third in this calculation. That's a way to think about it. This is a mask, okay? And these zeros are blanking out your second and third coordinate, and that 1 is just taking the first one wholesale, okay? And so, anyway, 1 times 2, 0 times 4, 0 times 1, boom, okay? It's going to result in a 2, all right? Here we go, 0 times 2, 0, 1 times 4, 4, and then 0 times 1, 0. So we get 4. Again, we're just getting what we entered in, okay? 0 times 2, 0, 0 times 4, 0, 1 times 1, 1. And we just get what we fed in. So the identity matrix just gives you whatever you feed it, and that's going to be important, okay? Yes?
Did the second array have to be of height 3 because the height of the identity matrix was 3, or because the width of the identity matrix was 3?
I think the width. But it's been a while since I did linear algebra too. You know, the last time I cared about a matrix? In 440 a couple weeks ago, we watched the Matrix film. But beyond that, 1 year ago is when I last cared about this matrix, okay? I tend to just use this, but it is interesting to know. Okay, so basically the identity matrix is just giving us our original vector, our original coordinate that we feed in. Okay, you can think of these matrices, and it helped me out a lot when I did so, as functions. They simply take a certain set of numbers in, they do some operation on it, and then out comes cool numbers that hopefully have some unique transformation that we want. Okay, like moving or rotating or scaling. The challenge, just like when you're learning computer science in the first place, is, okay, I need to make a function that does something cool. How on earth do I design a function that does what I want? Okay? And so we need to create some matrices that do interesting things, okay? Translation. If I have a 2 and a 4 coordinate and I want to move somewhere, I need a matrix that's going to do that for me, okay? How can I do this? What would happen if I put like a number here? Can you predict what would happen? And I could put any number here. I could put a 9 here. I could put a 1 here. Yes?
The scale would increase like based on
the scale? This stuff is really hard. I always forget, personally. Yes? One thing to notice, one thing that's really interesting, okay? These two cells are really powerful. Why? Because no matter what we feed in, okay, these two cells up here are always going to get a 1. They're always going to multiply by 1, okay, always. Why? Because we have that 1 there, okay? I'll prove it to you on the second row. Boom, 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 okay? Whatever I put in this 0 right here, this cell will get multiplied by 1, all right? And so, and by the way, yes, it's going to affect this row, okay? If I put something here, it's going to affect, multiply by 1 and affect this second row. And if I put something here, it's going to multiply by 1 and affect the first row. And so we see we've got some little tools here. We got these two cells that can do things for us. If we want to add something to the first component, we can put a number here to make it so. Want to alter the second component via some addition? You can put that number here instead. Okay, and it just always works. The math, the operations, the matrix multiplication is annoying. It's an operation I always forget how to do. It seems a bit arbitrary, but this is how it works out. How can we manipulate these numbers to make our 2-4 position move? We're going to keep this identity matrix. We're going to add something to these two cells right here. I'm going to call this Tx and Ty. You want to translate on the x-axis? Here you go. You want to translate on the y-axis, you put that number here, okay? In this way, we can design a matrix, okay, to do whatever we want. I call these hyperparameters, okay? When you alter these cells, it changes the function, okay? And now the function does something else, does something new, okay? This is referred to right here as the translation matrix. You can apply this matrix to any 2D coordinate coming in, and it's going to move that coordinate around. It's really nice, okay? So, for example, you could put a 5 and a 1 here. What does that mean? Well, I want to move 5 to the right and 1 up, okay? So let's see what happens, all right? You're going to go 1 times 2, so we got 2. We're back to our original x position. 0 times 4, that does nothing, and then 1 times 5, we add that, okay? It's going to end up being 7, all right? What about on the second row? 0 times 2 is nothing. 1 times 4 gets us our original number 4, our original y position, and then we add 1 times 1. So 1. We just changed the x value by 5 and the y value by 1. Isn't that exactly what we were looking for? And our new position is 7, 5. We, of course, ignore the 1, the homogeneous coordinate that gets chopped off at the end, okay? Good. It worked. All right. It worked just the way we want. We want to go to west. We use negative numbers, okay? No big deal. What about scale? How can we pack the scale operation into this matrix? And you're thinking to yourself, well, you know, answer me this. What should we do if we want a new scale of 1? What do we do? What do we do here? What can we do? I want to multiply all these numbers I'm feeding in by 1. What do we do to make that happen? Wait a second. Wait a second. That's just the identity matrix, right? The identity matrix is set up so that all these numbers we feed in get multiplied by 1, okay? And so wait a second. What if instead of the 1, 1, 1 identity matrix, what if we change these 1s to 2? What would happen? Well, we can actually work it out, right? If this were a 2, okay, we would get 2 times 2, so 4 times 0, 0. So our 2 has gone to 4. On the second row, we go 0 times 2, we don't care about that one, 2 times 4. So instead of a 4 here, we're going to have an 8, okay? Right? And, there we go. We have figured out scale. And then on the final one, we probably don't want to mess with this one. Okay, that could mess things up. Yes?
Why would that scale us, not just move us to 4, 8?
It would, well, it's scaling the vector, right? So if you have, what does it mean to scale a number like this, a 2D coordinate? What would you prefer?
Like, would the scale coordinate by default be something like 2, 4, or would it be just like 1, 1 is our basic non-scale numbers?
I think 0, 0 would be your basic. So the local coordinate system, it's going to push every coordinate out from that centered point. 0, 0, right?
So if it's 0, 0, how does this work if everything's just getting multiplied by 0?
It's not getting multiplied by 0. So the let me think about this. The center of your coordinate space here is going to be 0, 0. What happens is if you make this 2, this number is going to kind of be pushed away from that center. It's going to be scaled out. If you think of an image, let's see. Here's our coordinate. Riddle. Okay. We got 0, 0 right here. If we have a point, let's say a point that forms a nice happy house or something. Okay. When you do the scaling, right, this is going to double. So it's going to come out here. This is going to double, come out here, 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 here. You just scaled, right? Now, each individual point, you're right, it looks like it just moved. But when you apply this to all the points that form a mesh or a sprite, it's going to get a scale effect. So that's the situation. Okay, so, right, what we've got here is the scale matrix. And we have TS and TS. This is your scale factor. And you can change it to whatever you want, okay? If you go 3, 2, you're saying, hey, actually, wait a second. TX, I think that should be TXTY or SXXY, actually. Hold on. I'm going to change it. New course. Those new course vibes. Okay, there we go. So we got SX and SY. And if you alter these things, right, this is going to give you a different scale on the x-axis than you do get on the y-axis. Okay? And so you get something like this. Okay? You have tripled your x-axis position, and you have doubled your y-axis. You do this to all the points, and you get the effect of a scale, which is kind of cool. Okay? Scaled by SX and XY. The rotation operation, how's about it? Anyone really up to snuff on their trig? This one is a mess. Yeah, I looked this one up myself. Okay? This is a good one you might want to just memorize. Okay? Does anyone actually remember this off the top of their head? You can sort of kind of work it out if you look at the unit circle long enough. I'm not going to put you through that. So here it is, okay? Yeah, basically remember your trig, all right? Here's the situation. Nasty. Okay? Nasty. Something that is a little bit of interest to us, something you might want to take note of right away, is the fact that we're not blanking out some of these values anymore, okay? On the x-axis, when we're calculating the x-axis location, it actually now matters where we were on the y, okay? And also vice versa, when we're calculating the y position, it mattered where we were on the x position, okay? But basically, the parameter here that you have, the parameter you care about, is this theta in here. This is your rotation angle. So you'll feed this rotation angle in. It's in radians in this case. And you will get a value that is going to transform your point. So I'll demonstrate it to you, to prove it to you, okay? This looks messy, all right, but it does work. Here is our original point of 2, 4, okay? And again, this is not in SDL units. The y-axis would be flipped, okay? But what we're going to do here is we're going to go ahead and we're going to rotate by 90 degrees. That is pi over 2, okay? And by looking at the unit circle, we can kind of figure out what these values are going to be, okay? So what is cosine of 90 degrees, pi over 2? What is it? 1. Yeah, how do you know this? Okay. Actually, no, it's 0. Close though.
Oh, right, cosine.
Yes.
Sorry.
Cosine, you're looking at the x component, okay, on the unit circle. 90, pi over 2. So pi over 2, let's go like this. We're done here. What do we have? Cosine gets 0. Sine is 1, okay? So 0, negative 1, 1, 0, okay? And thus, there we go. Well, what do we have? Let's go ahead and work this out, okay? We got 0 times 2, that's nothing. Negative 1 times 4, so negative 4, okay? Boom, so negative 4 goes in there. What? 1, 2, so we got 2, 0, 0. Okay, so 2, and then 1. Okay? Is that what we wanted? Let's look. That is 2, 4, 1, and this is what happened. That looks kind of like a 90-degree turn, doesn't it? Looking pretty good to me. Okay? And so, yeah, we rotated by theta, 90 degrees. Now, this is great. Don't ask me for a proof. I could probably do one, but we're going to be here for a while. My head's going to hurt afterward, okay? Because looking at all this is already making my head hurt a good bit. So anyway, these designs for matrices, right? Mathematicians worked on these for a good while to find them for you. And some of them are kind of obvious, and some of them, like the rotation, not quite as much. But these transformations are real. You can design a matrix that will do wonderful things for you, okay? And one question you might ask is, well, you know what? We have 3 different matrices. We have one matrix for translation, we have another matrix for rotation, and another for scale. So a question is, can we combine them? Can you mix matrices together? And the answer is yes, okay? Can we pack all 3 of these matrices into one matrix, okay? Well, here we have the identity matrix. We have the translation matrix next. Can I add in the scale? Can I add in the scale operation without messing up all my translation goodies? Can I do that?
You could add it in the 3rd row.
Well, I can add it just like this. They're not even using the same cells, okay? Now I've got the ST matrix, the scale transform matrix, okay? Now I'm missing rotation. Can I add those in? And the answer is yes. Okay? If you're curious, the empty cells just get the values and we multiply in to combine the scale and the rotation. Okay? And so here we have the SRT matrix, okay? Otherwise known as the transform matrix, sometimes called the 2D affine transformation matrix. This is one of the classic universal matrices that you should probably all memorize, okay? It's not too bad, and especially when you kind of walk yourself through it, right? It's going to be easier to memorize, especially translation, super easy. Scale, super easy. The rotation stuff, all right? But super powerful, you will see this transformation matrix in every engine, or at least you'll see its 3D version, okay? If you want the 3D version of this, you have to add one more row and column. It's a 4x4. And then all of the vectors that you feed in have to be a 4-unit vector for x, y, z, and then the 1 that makes the math work out, okay? And so this is it, okay? This is the thing that hopefully, if you know it and play around with it a bit, even in some code maybe from time to time, you will be able to get past any interviews that might show up and ask you about it. You might even consider using matrices on your homework. I'm a little bit nervous about you doing that because the staff solution doesn't do it. And off by 1 errors, right? Are you using matrices? The staff solution doesn't do that. You know, you might get in trouble, right? The parameters here are the ones you'd expect. So for position, you can specify an X and a Y. For rotation, you can specify an angle. And for scale, you can specify an X and a Y. Okay? It looks pretty much exactly like the UI that we saw in all those game engines. Okay? Except the game engines, 3D game engines, they're going to have that extra Z parameter. Okay? And so every time you see that transform now, that transform component when you're using Unity, or maybe you're using Unreal Engine or Godot, I want you to think about this, okay? And hopefully it'll make you feel just a little bit nice inside to be like, oh, I kind of know what's going on here, okay? I kind of know what's under the hood, all right? Your usage on homework 5, okay? I believe, I haven't checked this in a while, but I believe it was possible last year to use matrix data types with GLM. GLM provides them. What you want to be sure is that the components are being stored as floats, okay? Floats, floats, floats. If they're doubles, okay, be careful. The staff solution doesn't use them. It doesn't use matrices on any of these assignments coming up, okay? And so my recommendation would be to study this matrix, have fun with it, mess around with it. Maybe don't use it on your homeworks. But if you want to get a shot, it's not that hard to rip it out and put the other stuff in, okay? The manual stuff. Use the float version. Very common that this transformation matrix shows up in game development interviews. And it will definitely show up on your next quiz. You can guarantee it. I've already been looking at the question, okay? And hopefully I won't mess that one up, all right? Like I messed the last quiz. I messed an easy question up. Not sure what happened. I think Canvas might have trolled me or something. The UI for editing quizzes, is a disaster, okay? Yeah, I'll show it to you sometime. Okay, we have 2 minutes before office hours begins. Does anyone have any questions? Are you like half raising your hand?
Like, it's a stupid question, but how do you render an image in STL?
How do you render an image in STL?
Because I ran through it, I'm like, I know how that works. AutoGrader. Yeah, you didn't render shit. Oh, well, that's one.
Well, yeah, you should ask me. But we literally just went over that in the intro to STL. Like, what functions should you call? Yeah, well, be careful. Make sure you're calling the functions you need to in the helper. Okay. Now, the AutoGrader, unless I have a typo or have a bug in my AutoGrader, probably, it's gonna tell you when it says, "Hey, you're using the vanilla version of something that I want you to use the helper for."
Right, it didn't build at first for that, and then next time it's like, oh yeah, you're just putting a blank screen. Oh, that's not good.
Yeah. Well, you should be able to test that locally, right? So download those test cases just like I showed you. Throw them next to your code and see if it works locally. If it doesn't work, well, you can easily debug locally. And then if it works locally, it probably will work on AutoGrader. The scariest bugs are when it works locally, but on the AutoGrader it does not, because that has me wondering to myself, do we have an AutoGrader bug? Do I need to go in? What's really nice is that if you let me know about this, even if I'm at home, what I can do is I can clone your repo, okay? I can clone your repo, start poking and prodding it myself, which is what I did with Ethan yesterday to find the double and the truncation issues. Yeah, the big issue is just a lot of us are at some point not rounding because that's illegal, but we're casting to an int, even implicitly. And if you cast to an int at the wrong time and then you use that int in the further calculation, depending on what part of the calculation you do that in, you could end up with a y pixel of 67 versus 66.5, which will get rounded down. 1 pixel off, boom, okay? We're in trouble. So anyway, okay. Please let me know if you have any questions. If you'd like me to help you get STL set up, I might be able to help you with that. One quick thing, I saw some people on Mac. It's always Mac, it seems. It's always Xcode. Some people on Xcode were having problems with dynamic linking. They would get a DYLD or something error, something like that when you go to run. It builds successfully, but then it goes to run and it instantly fails. With the RPath, that's usually the issue. So in your Xcode settings, there's a setting called RPath, and you need to set it to look for your frameworks, okay? That means, right, when you run the code, you build, that build finishes, you start running the software needs to dynamically link with the frameworks. They find it on the RPath, they link, and we're off to the races. Yes?
That also fixes an error on Mac AutoGrader. Like I had that working on my local, and then I added that, and it fixed it on AutoGrader.
Oh, great. Great. I think I'm going to go re-record some of that footage. I'm going to add that on to the Xcode demonstration.
In the Discord, someone put what they did and what they put there, and let's look at that.
Gotcha. Okay. Cool. All right. Maybe I'll include footage of that discussion so you can live forever. 5 years from now, they'll be looking at your RPath advice, maybe. Okay, everyone, that's it for me. I'm going to head off to the restroom. I'll be back really quickly, and we'll start office hours. I'll be here for 2 hours. Okay, thank you for joining us. Okay, everyone online, take care. Thank you for joining us for a slightly more mathy lecture than normal. And I'll see you next time. Bye-bye.